morning, everyone. Today is the day. In our last video, I told you we'll be talking about variation later, and today we're talking about variation. Please, if you're just seeing this video for the first time, I'd like you to on your notification bell so in case I drop videos, because on this channel we talked about mathematics, problems in mathematics, and I bring you solutions to all problems in mathematics. So let's carry on. Today, we'll be talking about variation, and under variation, we'll be talking about direct variation, inverse variation, joint variation, partial variation, and word problem leading to variation. So please sit tight, and before we go into what direct variation really means, we have to talk about what variation is. When we talk about variation, we've been talking about subject of formula since a few weeks now. When we say subject of the formula, we can say 3x plus 2 equals 5. And you will be asked to make x subject of the formula. In this case, you will be having your x to be equals to 1. Please, if you don't know how I get 1, I would like you to go back to the first video I dropped on subject of formula, and you will understand how I get 1. And this is a variation that involves just only one variable. So what do I mean? Let's say we have x plus, sorry, let's say we have x equals 2y. There is a certain connection between the value of x and y in this type of equation. That is, if anything happens to the value of x, it will also affect the value of y. Let's see. Let's say x equals 1. If x equals to 1, that is 1 equals to 2y, then your y is equals to what? Yes, 1 over 2. This will be your value of y if x equals to 1. Now, let's say x equals to 2. That is, if x is equals to 2, let's see what our y is. You have x equals to 2y, then 2 equals to 2y. You have your y to be equals to 2 over 2, your y equals 1. Can you see? As the value of x is being affected, it also affects the value of y. This simply means that x varies in a certain way with y. And let's say, as the value of x is increasing, the value of y is also increasing. Here, you have it to be 1 over 2, which is half, when x is equals to 1. And when x increases to 2, you have the value of y to be what? 1. Let's see when x equals to 3. When x equals to 3, the value of your y will be what? You have y to be equals to 3 over 2, which is also greater than 1. That is, as the value of x is increasing, the value of y is also increasing. In this type of situation, we say x varies directly to y, because increase in the value of x also affects increase in the value of y. Let's have an example on what direct variation really means. This is an explanation on direct variation. So let me give an example on direct variation. So this is an example on direct variation. The question says, the circumference of a circle C varies directly as the diameter of the circle D. That is, the circumference of the circle is represented as C and the diameter is represented as D. It now says a circle diameter 14 centimeter has a circumference of 44. Find a formula relating the circumference to the diameter. B, the circumference if diameter is 3.5 centimeter. 2, diameter if the circumference is 33 centimeter. This is a very good example on direct variation. And how do you go about this? Firstly, when they said C varies direct to the diameter of a circle D, that is, C is directly proportional to D. This is the first thing you do. We have what we call a proportionality sign. So it is like this. You have a proportionality sign like this, which is an alpha, which is an alpha. So you can say C is directly proportional to D. That's the first thing you do. You show how they are the variation, the type of variation they have between each other. And when you say C is directly proportional to D, this proportionality sign cannot be used to solve an equation because it is not yet an equation. What you have to do is you have to convert this proportionality sign into an equals sign. And for you to convert a proportionality sign to equal sign, you have to introduce a constant, and the constant will be what will relate your C to D, that is your circumference to your diameter. And we normally represent the constant as K. You can use any letter you want. You can use A, B, C, D, anything. But I like to use K to simplify it because most people use K out there. When you see K, you won't get it confused. That means your C is equals to KD. Can you notice that immediately I introduce the constant, the proportionality sign changes to an equals sign? Are you getting it? So this is the equation of this question. That is, they said the circumference of a circle C, which is this, varies directly as the diameter of the circle D. This is what it's trying to say. That is, the C varies directly as D, and I change the proportionality sign to equals sign. And the next thing for you to do now is what? Yes, find the constant. The constant we introduce here is an unknown, although we already have two unknowns before introducing the constant sign. But if you go forward and if you go further in the question says a circle diameter 14 centimeter, that is, the diameter of a circle is 14 centimeter. That means you have your D to be 14, has a circumference of 44 centimeter. That is a circumference of 44 centimeter. Don't forget we are working in centimeter, please. It's very important not to leave your unit aside. So we are working with centimeter. Now, what you have to do is to find the constant, and the next thing to do is now to make your constant subject of the formula in this equation. And if you want to make your constant subject of the formula, then your C here and your D here will be in this form, because you have to divide both sides by D to eliminate D from this side and transfer it to the other side, so that you'll be left with your K, which is your constant. So now your K equals your 44 over 14. Your K equals your 44 over 14. What you do next now is to do what? 2 here, 7, 2 here, that's 22, which is 22 over 7. That means your your K is equals to 27, and you have your C to be equals to 22 over 7 D. This is the answer to the first question, that says a formula relating the circumference to the diameter, because you cannot have K, which is the constant, also as unknown in the formula, so you have to find the value of it. That means you've gotten the value of your K to be what? Yes, to be 22 over 7, and this is the formula relating the two together, which is our answer to question A. Now let's move forward to the question B. It says the one circumference if diameter is 3.5. Since we know that the formula relating the two together now is C equals 22 over 7D, you are now told to find the circumference if your diameter is 3.5. What you have to do now is to just substitute 3.5 in place of the diameter. Your C equals to 22 over 7 multiplied by what? 3.5. So your 3.5 here 1, your 3.5 here goes in 2. So you have it to be 22 over 2, which equals to 11 centimeter. That is your C is equals to 11 centimeter. Your C equals 11 centimeter. Now let's go to the next one, which is the diameter if the circumference is 33 centimeter. With the formula that says C equals 22 over 7D, and you're looking for the diameter in this time around when your circumference is 33 centimeter. What you have to do is to make your diameter subject of the formula. To do that, you can multiply both sides by 7. With that, you have 7C to be equals to 22, sorry, 7C, I wrote it like X. 7C to be equals to 22D, and your D equals to 7C over 22. This is your D. And the next thing to do now is what? Yes, substitute your C. So you have your D to be equals to 7 multiplied by 33. Sorry, 7 multiplied by 33 over 22. So you have 11 here to be 3. You have 11 here to be 2. So you have your D to be 21 over 2 centimeter. And you can also write it as 10.5 centimeter. This is the final solution to the problem.